Hi, in today's video, we're still on section 3 of chapter 2. We're going to talk about zeros of a polynomial and their multiplicity. So that word multiplicity might be a new keyword for today's lesson. And the word zeros you guys should be familiar with. But just to clarify and to give you a refresher, zeros are x-intercepts. Another word for x-intercept solutions of the function. And as we talked about that in one of our Bellword questions, the SAT question, the best way to find x-intercepts or to be able to see them nicely is from a factored form. So as you notice in those problems, 39 through 42, all functions are given in factored form. But if you take a quick look, you can see that there are some exponents on each of those parentheses. So let's keep that in mind and see what do these exponents do to the function, to the graph. How are we going to deal with that? So we're going to start by interpreting or finding the zeros. And the question says, state the degree. Now, in the past, what we have done, we worked with, for example, x to the power of 5 plus 2x squared plus 3. Like, let's say 7x to the power of 5. So the degree of this polynomial would be 5. And this is a standard form. So in a standard form, we look at the highest exponent, and that would be the degree. Sometimes it's a little bit tricky where they will give you negative 2x cubed plus 5x to the 7th plus 10, for example. This is not a standard form because you need to rearrange it nicely. And once you rearrange it nicely, the highest exponent will also be the degree. So degree is 7. In our case right here, it's a little bit different because it's a factored form as we just talked about. So from a factored form, we cannot look at the highest degree and say, oh, this is the degree is 2. Or this is the degree is 3. Or this is the degree of 4. Not correct. And I'm going to give you an easy example right here. If I have x squared times x cubed, and this is a multiplication. When we multiply, we add exponents. It will be x to the power 5. So factored form is a multiplication as well. So what we need to do to find the degree, we're going to add the exponents. So exponent of 1, exponent of 2, the degree will be 3. Exponent of 3, exponent of 1, the degree will be 4. 3 and 2, degree 5, 2 and 4, the degree is 6. And again, this is just because we have a factored form. So from a factored form, let's put that. To find the degree, you're going to have to add exponents. So let's take number 39. And to find the zeros, it's easy to find the zeros from a factored form. The x minus 3 would give us the 0, or the x-intercept 3. Whenever you have x by itself, it means 0 is one of the x-intercepts. So 0 and 3 will be the x-intercepts. When it says state the multiplicity, it simply means multiple. The word multiplicity comes from multiple, which means more than one. Now, this is a one time. So one time I have x to the power of 0, but 2 times I have x to the power of 3. So I would say multiplicity of 2. In other words, I can rewrite this as x minus 3, x minus 3, and I can see how 3 repeats twice, 1, 0 only once. So anything that has a power of 1, I do not need to list its multiplicity because it's not multiple. It's not present multiple times. So what does multiplicity do to the zeros? Well, it actually does. It changes the shape of the graph at those zeros. So if I graph 0 as an x-intercept and 3, 1, 2, 3, and I need also to look at the end behavior, and I'm still working on 39. So the degree is odd, the leading coefficient is positive, so it's gonna be a down, up, and behavior. So it's gonna start down, and it's gonna end up. So what this 2 means, it means at 3, it's gonna act like a parabola. So when it goes through the 0, it's gonna land on 3 and it's gonna bounce on 3. So that even multiplicity make it look like a parabola at 3. Odd multiplicity make it go through that x-intercept. So if you look at number 41, I have 1 as a 0, and I have -2 as another 0. -2 has an even multiplicity, and 1 has an odd multiplicity. So I need to look also, the degree is odd, leading coefficient is positive, down, up. So this graph is gonna start down, and it's gonna bounce at -2, which means it's gonna form a parabola shape, and then it's gonna go up, which we don't care what happens in between, we just need a general sketch. So odd multiplicity graph goes through the x-intercept, and even multiplicity, the graph bounces at this x-intercept. And the word bounces, it means it forms a parabola. Now, whether this parabola or this parabola, it depends on the end behavior, and that's why we analyze the end behavior as well. So now it's your turn to complete the other problems as a group.